So we take a look at this part of the question instantly. It's obvious we're going to do something with spectroscopy. But we do need to read this bit up here. Don't miss this. There's often really key pieces of information here. So compound D is a neutral compound, which is a structural isomer of propanoic acid. So we know all the carbons, hydrogens, oxygens it's got. But it is neutral. This means it is not an acid. It's not just carboxylic acid with some stuff moving around. We have got structural isomers where the oxygens move around. We can take a quick look at the spectra and we should be able to see that we've got CHs here, we've got an OH here, and we've got C double bond O over here at 1700. We might also notice on that spectrum that this is quite a sharp and nicely rounded OH here. That usually means alcohol, as opposed to carboxylic acid one, which tends to be very spread out and a bit shorter and really jaggedy. So let's get that into view. Two possible structures. Explain all your reasoning. So let's start with not just leaving that up there, but going, I know I've got an OH because I've got a peak at 3400 here, and that's because I'm just taking that peak there and reading off where it points to, and I'm going to look at where that peak here points to as well, and that's at 1720 where that one points, and write that one down. I'm also going to point out that I know these must be on different carbon atoms because this is neutral. If they were on the same carbon atom, this would not be neutral, it would be a carboxylic acid. So therefore, I started off by sketching 3 in a row, because there's nothing else you can do with 3 in a row, and I've put the double bond O on the end here, and I've put the alcohol there, and my alternative is double bond here, alcohol on the end. And my third alternative is double bond in the middle, alcohol on the end. So I've had a little sketch, but I can't leave those as my final answers. I really ought to put the hydrogens around those after that, which I've got alternative structures at the bottom which would be allowable. So you could do skeletal structures, you could do the displayed structures and just put those hydrogens on all round, or you could do structural formulae here. Remembering though that when it is an aldehyde, a couple of things to remember. One is you go CHO, because you always do your H's before your oxygens when you write your formula out, and if you were doing it skeletal, no CHs are ever shown, only OHs or NHs or other H's, but CHs don't get shown.